Good morning, all. Welcome to Attika's March webinar for 2026. So each month we'll be holding regular webinars with subject matter and industry experts in the commercial and industrial building sector. And this month we want to welcome Judah and the team from Paneltec on. So Paneltec are a facade design and supply company with a wide range of experience across a variety of buildings. So I brought them on to share practical insights around design decisions, material selection, cost and program risk. So just to run through the agenda. So Judah's going to give us some information around the industry context, how facade challenges can be resolved earlier, optimum design outcomes and cost perceptions, and then wrapping it up with some material choice and long-term considerations. And then we'll take some question and answers from the team. So over to you, Judah. Kick us off.
Thanks, Amanda. Judah from Paneltec. We've been in the industry since 2016, supplying commercial facades. Over the past few years, earlier we focused on providing pre-finished aluminiums, low cost or premium fibre cements, but now moving more into the actual design and deliver of the full facade system from early on right through to actually supplying on site. So quite a work with a number of people right across New Zealand, Kaitaia to Invercargill. So see quite a variety of different buildings and types, and as you would know, the different types of consenting authorities and councils throughout the country has a big impact on the way that we build. I just thought I'd start off with this. It's a fairly confronting exactly what happened on this particular event, but it really shaped the way after of what happened soon after we actually started into this in 2017 of this disaster in London. Had a severe impact on the facade industry right across the world and New Zealand. Right now, building code, the way that we build today, has had quite a number of impacts in this. I guess if you could view New Zealand as somewhat lucky in the fact that we have relatively few high-rises comparison to Australia and around the world. But I guess we view as New Zealand as an up-and-coming growing area. But so we need to work through this. I guess one of the main things that happened in that particular point was the way that fire impacted is that I guess the reaction immediately was that it was the cladding that caused the whole fire and the fire spread. But what we really delved into further down the track was the full system from the concrete out. So with this particular fire, they had a polyethylene cladding, which in New Zealand is made up of often 0.3 aluminium. It's got a polyethylene core and 0.3 rear, and it's only used for signage. And so it's not something that we'd be using over here, but at the same time, it is extremely combustible. And some of the other major things that impacted this was it had no fire barriers, it had combustible insulation, had no sprinkler system, and had a very poor evacuation system. So all those things, plus many other design issues, led to this tragedy of how so many 70 people passing away. So I think that probably leads us on to what we had now in New Zealand is that a lot of knee-jerk reaction around. We had a focus in our building code mainly focused on small fire testing, such as like an ISO 5660 small scale testing, linked with a test in America, which really didn't reflect how we built in New Zealand, and also many suppliers could get away with actually making polyethylene pass in the building in those tests, which obviously is not extreme enough. And so we've changed a lot, and we can cover off in more detail exactly. You can see more detail out on what those tests are. but the full-scale fire test now that most rely on would be what they call a BSA 414 test. And brands have got a testing facility, so there's a few in Australia and Dubai as well. So a lot of our cladding products are being tested on this, and it does give you a pretty interesting view on how different panels react, especially when the fire's over 1,000 degrees. The aluminium melts at 660, so it gives you a bit of an idea on how those tests react. Does that cover it enough there, Amanzo?
Yeah, that's good. So obviously that, from what I'm taking away, you've added a fair degree of conservatism and probably a bit of misinformation or around where the real issue was. So I guess bringing that into today, for what you're saying, is that those polyurethane type claddings are not. Can that still be used under the current code, or has that been written out through this process?
Yeah, so if you looked at just the building code, you could actually use it up to 10 metres high, but you'd get absolutely no insurance on it, and it would be just no one would do it. But if you looked at it just in the law, you could do it, but obviously no one's going to do it.
Yeah, sure. Yeah. So it's being caught. I guess it's probably a bit like the your EPS type panel that used to get used for cool stores. Technically, you could use it, but it's uninsurable. So that then, I guess, self-corrects the market from that respect.
I guess the other point in New Zealand is we have a lot more. We had a lot more since there is buildings out there now in New Zealand with polyethylene cladding on them, but we've always had insulation, had fire barriers and sprinkler systems, which obviously have a massive impact on the way that a fire will spread. Being that, the problem with this one is the fire was actually behind the cladding, which makes it virtually impossible for the fire engines to, or the fireys to even put the thing out.
Yes. Okay. So there's the methodology they were using over there, like you said, as in what we would have typically done, actually caused an overreaction. And I guess potentially for developers may still have some of those legacy, anecdotal things in the back of their mind. Whereas you're saying now with the right product, that is, I guess no longer a risk in the sense that it was 10 years ago.
Yeah, so now obviously instead of just looking just at the cladding, we're looking at the overall system from the framing out, depending on the height of the project and the complexity of it. Yeah, so this has been an interesting twist a little bit, probably in the recent years, and it's mostly been driven by Auckland Council, and it's got its advantages throughout the whole system. How traditionally it worked is that we would follow the black side of it. So there's obviously more stages in the building than this, but just narrowed it down. So the architect or the developer would do the design, would send in standard details, go through resource consent, and then the installer would be engaged, which we would be working with that and then working with the builders. So just to clarify that, Paneltec as a company doesn't install. We would get support installers in that would contract directly to a builder for that supply and install price, but then they would do a shop drawings. Obviously, it depends on the height of the project, but any higher, more complex jobs would be requiring shop drawings. And then a lot of those details would result in construction, which does work on a low-rise, two-story commercial office. But as soon as you get a bit higher than that, where you're dealing a bit more complexity in the building code and also different junctions with materials, that's where we've really been, as Paneltec moving more into design, have become more and more involved. And really the drive again came back from Auckland Council saying, look, we've got these detailed plans in here, but we don't actually have enough detail. They give us a kind of a concept, but we need the shop drawings, which shop drawings are highly detailed plans, and then often backed with a PS1, engineering of PS1. So by doing this, and especially going back to the complex jobs, it does resolve a lot of these design buildability issues on site. So it pulls in things like fire barriers in the E2 area. So it pulls in that whole each part of the building code and highly detailed. So when council gets the plans, shop drawings done often by the supplier, and that in turn gives them would cut a lot of the RFIs out because of the amount of detail. So then that streamlines it going through consent, and back to my point before, because Paneltec doesn't install, means that when we get engaged early on with design, not often with shop drawings, it does lock a material in, but because we don't install, means that we can the builder or whoever the client is can get multiple supply and install prices, which is the majority of the cost of the facade, being the materials only around 20 to 30% of the total facade, depending on how complex it is. So that gives you a bit of an idea. By resolving these facade systems early on, cuts the RFIs, and obviously it makes it a lot easier for an installer to price, being they've got full details to price on rather than a concept kind of ideas from an architect's point of view.
If we just go back on a slide, I was just going to pick on a couple of points because I can sort of see some similarities even when you're using standardized metal claddings. Like it's often a case where flashing details would just be used as generic details, and all of that gets worked out on site, or often can, because it's an E2 type drawing that's the council's seen before. It's easy to put on. So I can certainly see from an architect's point of view how they like to keep stuff simple and minimal details earlier on. And the overall, for that inserting that shop drawing timeline after concept and consent, how much of an impact does that have on that overall timeline? Like obviously things can be done in parallel, but does that add a number of weeks to be planned in on a design program?
If we're going to do shop drawings before building consent.
That's right, yeah.
Yeah, so a lot of those details, instead of the architect, they would do very basic concept details, and we can be working in conjunction with the architect, so it doesn't necessarily add lots of time onto it, because you're kind of working, the architect essentially is working on other parts of the consent, where we work on that package and essentially plug into theirs, and that'll give you everything from the consenting documentation to must spec write-ups or whatever is needed for that facade package. Which is
got it. Okay, so that's potentially adding quite a bit of value to the architect or whoever the designer is, because they're able to get those shop drawings done by someone who I guess is detailing that type of cladding, every day, so to speak, compared to an architect who's potentially using multiple claddings off multiple projects. I can see that adding a lot of efficiency if that's planned well and they're working together, compared to an architect trying to do the details and then having to manage the RFIs and go back and forth with yourselves or the designer, or the supplier for their approved details.
Yeah, I guess there's another point in here. This is where we're moving to, which kind of gives you a bit of an idea. We've got a methodology we're working through, which is really driven from. It's mainly for your complex jobs, your multi-reses, your reclads, those kind of projects. But essentially, we would do that whole design package, providing engineering, providing shop drawings, providing Revit details that would plug straight into their model, and looking after that total package, which again reduces a lot of the architecture work. And to your point, someone that just focuses on that area, that just on the cladding, and we'd be looking from the rigid air barrier out. So that would be from the E2 barrier right out. So all the risk is covered by one professional indemnity, and it makes it very clear as to who's responsible for all that designing and detailing. And that detailing goes right through to the final construction or to actually being installed. I guess the material choices. This is just I just picked a couple. There's lots of different options, but gives you just a bit of an idea, kind of on some of our products. But there's obviously lots of other products you can do comparisons on. But this is one that that keeps coming up because New Zealand has added a lot of fibre cement over the past. Excutech is very, very common. And just thought I'd do a very quick comparison as to the differences between a standard fibre cement, which you paint on site, versus Genesis, or other one would be on the market, would be like Equitone or Swiss Pearl is another product, which is our opposition products, but great products. So with the fibre cement, with the standard fibre cements, as point there, familiar, it's very low cost, but obviously you've got a lot of paint, a lot of maintenance, and you've got to paint it on site. So every 2-3 years, you need to repaint it, and which needs to scaff it, and then also any chips or cracks show up. But again, it's a low cost product. So that just to look at the more longer term thing, that's where you go to your true colour fibre cements. And so instead of that being a paint, it's actually a right through the fibre. So when you cut right through the 8mm or 10mm panel, it's right through it. So obviously you've got no painting on site, it's already done. And if there's any chipping or cracking, which is not chipping, it won't be cracking because it's a different process to your standard fibre cement, then it's all the colour right through. And then it doesn't, because it's not a paint, it doesn't actually fade because it's right in the fibre. So very long term, very low maintenance, but a different price bracket. But yeah, does that give you a bit of a comparison on those different things there, Manzo?
Yeah, that's good. Yeah, so fibre cement is like your typical, James Hardy, those types of product come in lots of different types of panels, and whether it's weatherboard or flat panels. But that is a common one we see, that people are trying to factor, work between the two, what's an efficient option and best for them. So it's good side comparison. Thanks.
So this slide is kind of pulling back again to the Greenfield fire, because it gives you a bit of an idea on the step through. These are all compliant cladding. I guess you could have added one more in there, which is the polyethylene cladding, but since it's not a facade material, I didn't include it. But to also give you a bit of an idea of the different types of products on there, was Endurabond, which is our fire-rated ACM panel. Other ones that people on the call might know would be like a Lucabond. Pollock would be other ones sitting in that fire-rated area. So they're all limited to 10 metres and below, because of the way the fire code works. Very well known, been around for a very long time, those kind of panels, very easy to machine. And just onto that oil canning, I don't know if others know about it, but it's something that comes up a lot, and I just might make a bit of a comparison with those, across those. So oil canning, you often see that on a big fascia, and it will be it's very easy to see in a thin metal, where it looks flat, but when the heat gets on it, it waves and crinkles, so it gives it and what that is basically the tension or the expansion of that material, because it's a single layer, means that there's nowhere for that tension to go, and so it's got a bow, it's got to move, and that's where the advantages of ACM, the likes of Endurabond and Enduracore, being multiple layers, means that actual oil canning cannot occur, because you've got a 0.5 aluminium face, you've got either a composite fire-rated core in the Endurabond, or in the Enduracore G2, it's a stamped aluminium core, and they are backed by 0.5 aluminium facing. So it means that when the heat hits the face, the core is at a different temperature, and the rear of the panel is a different temperature again, and so it keeps it perfectly stable. Whereas when you go to the 3 more solid, like the EnduraPlate, it's the other ones you might know, and there would be like a Galux or Paneltec would be another one, but they will oil can, because they're again the same as the thinner metal ones, but because the tension cannot go anywhere, because it's one sheet, means that by default there's no way for it to actually get rid of the oil canning. So I guess you've got different cores in that. So Endurabond fire aluminium core, so aluminium hydroxide and 25% polyethylene. So the aluminium hydroxide has a flame suppressant in it, gives off a moisture vapor, but it's again limited to those 10 meters. The Enduracore G2 has been probably a main go-to in New Zealand. It can be used for any height project. It's very light, so it's great for installation. Obviously, you can have two guys lifting a large panel around instead of multiple people machining it. You've got less material to take out, so the CNCs can go faster. And yeah, we get a lot of comments around that. There's a lot of color ranges, a lot of colors we have available in that. Doesn't oil can. But I guess when we move to the solid aluminium, again, can be used for any height projects. But it is more expensive, but it's often used where there's curves, because you can't curve Enduracore G2, but you can curve EnduraPlate. I guess the only last point I would make on those is the key advantage of any ACM panel is that they've got a paint process called a PVDF, which is done in the factory. It's quite thin, but it's known for its long-term color fast. And because the paint flexes, means that you can actually machine it off site, fabricate it into the panel, fabricate it into the shape, and install it. So it gets rid of a lot of those flashings that you would normally have on a project, because the panel can essentially be folded around and right underneath the window jamb or wherever into the soffiters to one big panel, versus the likes of if you were going to powder coat a 3mm panel, you'd have to fabricate the sheet, put it in place, take it off, powder coat it, put it back in again, and any time you curved it, it would crack. So it's across all those ranges, across any ACM or time material, they don't. That's the key advantages in those panels. Basically, you put it up there and you don't touch it again. It lasts a very long time, and it's very low maintenance, so it's great for commercial or high rise. So.
Great, thanks. That all canning one comes up quite a bit, and people often don't even know that's the term, but it's probably the most obvious place you often tend to see it is in your standing seam type claddings, where you've got a very wide tray, and it's often the colour profile people like now is a dark colour, and as that heats up, that can get quite a ripple in it. And it can even occur in your standard fire rib and those types of things, but I guess the architectural trend over the last few years of wide pans, dark colours hasn't helped that particular issue. And it certainly can be quite obvious in the sun and the right kind of conditions. Welcome any questions to put in the chat for Judah. I was just going to summarise probably a few things, just again, and a couple of questions I've had as we've gone through, but pretty broadly the questions developers should ask, and a lot of these can come from the experience with developers and owner occupiers are building their own building as well, is that often a lot of these thoughts about the type of cladding they want to use and that sort of thing can come up quite late in the discussion. So they'll get a concept done up, it looks really sharp, it's got a flat type of panel on it, and then that goes into design, and then questions come up, is it this product or that product, or is it a fibre cement, and all those sorts of things. And architects and even owner occupiers can have quite a bit of predisposition towards certain products, or they've heard that something's expensive, like the Paneltec type product, for example, and maybe they've got an idea in their head that fibre cement's half the price. But I'd really encourage people in those early stages is bring up your questions with your architect or your design and build company about what the claddings are, because it is important for your long-term performance and what the maintenance life cycle is moving fast. Go out and have a look at it. So find somewhere where it's been installed before in a similar colours and actually check it out, see if you like the look of it. But actually price out the options. Don't just take one person's word for Paneltec versus a fibre cement board. The art's roughly half the price or 75% more expensive, whatever the case is, because they tend to get bandied around quite a bit. Actually run comparisons, and it needs to be looked at in entirety. And I'll just give an example we often see, and it's a small example, but you might have an entranceway or an eyebrow coming out from a building, Judah, where it's coming out to go over top of a doorway. And the advantage of using that as Paneltec is that the product or aluminium type product the right one is that can actually be used to return and flash back up into the material as the roofing, whereas oftentimes that can actually get designed up with butanol and TPO and that sort of thing, which actually isn't particularly cheap as well. So it kind of needs to be looked as an all of system costs, not just one element. Um, and another part of it is that often the square meterages aren't enormous. And if you spread that as a percentage across the project, maybe a product does cost 20 or 30% more. But if it's 20 or 30% more on something that's maybe only a 70, 80, $150,000 item and you never have to paint it again, um, that is uh, um, quite a reasonable value add as well. Is something that we do see people not always tending to consider. Um, but for you, Judy, you'd be obviously connected a lot more wide range of projects. What are some of this kind of myths that people can have going in, or the things that sometimes they misinformed or disconnected information, or some of those anecdotes that don't actually always hold true that you hear in the industry?
Yeah, I think you've covered them well. I guess if you from that point of view, if you really look at it from what your brand or the style you're trying to achieve as your company brand, because we see it time and time again where we get a project that get right through a design and they're like, okay, no, we've got to save some money, so we go back to the likes of a paintable fibre cement, and that looks great for about 2 years, and then you've got to repaint that thing, and it's every time you drive past it, and I particularly see it more often probably because that's all that's what we see, that's what we
Yeah.
notice. But you just see that brand or that company brand is actually impacted by that because instead of having a clean black panel, for example, it's gone from black to grey to chalky, um, which is, I guess, need to. I fully support your point on looking at the overall facade, looking at the overall project rather than just that little component around that eyebrow or that entrance. But yeah, have to look at the whole life cycle, the whole maintenance cost, and yeah, absolutely go and have a look at it. We've got plenty of examples of projects that are 15, 20 years old, and you'll see them around. You'll go places around your own areas where it doesn't look any different. Keeps looking the same. So yeah, that's probably only my point on that one.
Yeah, good. Um, and I guess back into the budgetary things, which has been a pretty big issue with the industry over the last 3 or 4 years, as we had that massive spike in inflation, and then obviously construction markets really falling back. So there's quite a few challenges to make projects work. Um, I really encourage again, and this can particularly happen when an architect or a designer's got a long way developed, like you said, and then the budget implications come in to hit them because there's been quite a gap from initial estimates right through to how that design's developed through. So I guess in a broad discussion, I'd really encourage those who are looking at, building themselves or building to development to start with a budget, but then as the design goes through, have those iterative budgets and ask those questions and understand the implications of the decisions you're making along the way. Because so often that scope can creep all the way through, and then you get you get the revised price sort of 3 or 4 months into design, and then it's like, well, hang on, if I knew if that was all the cost implications, I would have made those decisions. But then you're running out of time because you've got a deadline and you're committed. So it's a really difficult situation where you get someone who's made some decisions but not fully understood some of those cost implications, and then trying to wind those backs is harder the further you get through, especially if you're through consenting. And like you say, you've been through all those RFIs on some of those weather tightness questions. And then if the whole system's changing, that cost gain you might get by switching out a cladding gets eroded. But also more broadly, I guess, on the cost implications side, and that's probably digressing from the webinar, but it's probably relevant, is that there's always a whole of project cost. Sometimes people fix out on certain things because that's where they've heard other people blew the budget or things went out, whereas it's more of a whole of budget, whole of project cost where maybe that extra 30 or 40 grand you spent on the front, you'd actually potentially save 50 or 60 in some other design smart somewhere else that aren't quite so obvious, that don't, maybe impact the building so much, rather than focusing on something that looks expensive, so to speak. But just a question come through, Judah, is around we would, what kind of application would you not recommend your type of product? Um, Something I like to ask people because everybody thinks their things works everywhere. Is there a type of project or thing you go, hang on, if I'm really straight up, we're probably not the best option for?
Yeah, so I mean, I guess if we go back to back to the aluminium or pre-finished aluminium because that's probably the easier one to talk about. Um, Often on houses, low cost. I like townhouses, things like that. Townhouses, something that basically the ACM works where we want low maintenance, but it does give quite a commercial look. So you're not going to be. It's mainly around what kind of impact you want to do for that kind of project. So yeah, I mean you can get some houses that put them on that can impact the design. In regards to currently think about anything in particularly in durability or that because being aluminium it doesn't corrode, but it'd be mainly around the looks, which is what I think, and then same thing for fibre cements. That's obviously very much a budget, probably driven more than anything. You get a pre-finished fibre cements give a great longevity, but they are twice or three times the price of a standard painted fibre cement. Does that cover
That's
it
good.
all?
Yeah, that I guess probably from our point of view as working with different clients is that if you're looking at a relatively small office and you've just got some features and it's single level, and around the area, fibre cement may well be worth looking at because your cost to maintain is probably pretty minimal. Um,
Yeah.
and probably just another common misconception I was going to put out around is that a lot of square meter rates get thrown around for this type of product. But it's just important that you've got a QS or a designer build company or someone that's across the numbers understanding how those rates change depending on the complexity of the facade. Like if you've got a very large flat area of ACM, um, from our experience, that can be a lot more efficient per square meter than when there's suddenly a lot of cutout around detailing and corners and all those sorts of things. Um,
Yeah, and I guess that's where we definitely encourage people just reach out. It's not you're not fixing anything and reaching out to Paneltec and saying, "Hey, I've got this building," and again, if a Cargill or Kaitoa is going to be a different price to someone based in Auckland or Christchurch. So having those, and we can get installers to actually get direct pricing into those, and they can deal directly. So we don't stand in between the installer and the developer. It means they can deal directly with those installers, which will give them a huge amount of accuracy on their pricing and also some brilliant ideas as to efficiencies.
Very good. Awesome. Well, I don't think we have any other questions. We'll run slightly over time for half an hour. So, Jude, appreciate your input you've put through. We'll be getting this information up online. And using the best way for them to reach out you is either on LinkedIn or Google Paneltec. I'm sure they'll come up pretty quickly. And from our experience with dealing with the team, they're very responsive around getting those details, answering questions, and providing really good advice. So, appreciate your time once again. Thank you, and we'll talk again.
Thanks, Minto.
Cheers.